Right, welcome. So today will be the second part of the OVS lab sheet. All right. The plan is for me to explain to you all of the networking aspects of this. So hopefully by now you will have all installed Open vSwitch and you will have gone through the ordeal of compiling the program and configuring the OVS interfaces and hopefully be somewhere around the point where you're configuring the network cards on the operating system with all of the IP addresses and everything. So what I will explain today is mostly the network configuration. So what IP addresses you should be using where and so on. So as we're going through the lab sheet, so we're dealing with the installation of the software and everything. Once we get to the point where we create the RPM, then we start Open vSwitch. We reach the first milestone, which is the OVS VSCTL show. So if you've done this and it shows you the version 2.15 whatever, you've installed it correctly, hooray. The next part of the process is to actually configure all of the network cards that we need to have on the system. So the network cards that you will need to have on Prometheus are net28, net30, net31, and net32. Net28 will be bridged on subnet 28, so it will have the usual host plus 50 IP address, the Prometheus IP address you always had. And then you will have network cards 30, 31, and 32. For them, in order to figure out what IP addresses you need to have for them, you need to look at the a2.net subnets file. And in there, you will need to simply find your computer's name, see which line belongs to you, and then use the first usable IP address from this list. Okay, so if you're sitting on Android, for example, then your net 30 network card on Prometheus should be 30.17. Okay, so your network address is 30.16, your broadcast address is 30.19, and you can use 17 and 18 as the IP addresses for your network cards. The first network card that you'll have to configure is net30 on the host. The second network card you'll have to configure will be the network card inside the virtual machine VP2, let's call it, inside your cloud. Okay, inside Open Nebula. So that's where the second IP address of 30.18, for example, will actually be allocated to. Okay, now, if we go back to the lab sheet, so we have the network cards, we have the IP addresses that they need, we have the configuration examples of what your OVS should tell you and what the files should be like. So then the part that's left is to actually end up with an ifconfig that looks something like this. If you reach this point that your ifconfig has net 28, 30, 31, and 32, and you can ping google.com from Prometheus, you are okay with the networking on Prometheus itself. At this point, you should go into your cloud and you should go to VP0 and you should go into the template of VP0 and alter the template. You should go into your network and you should remove the BR0 or you should change it from BR0 to net28. Okay. If you save the changes on the template and then go back and instantiate your template again, so delete whatever was running before and instantiate it again, you will now have a new network card on your VP0 that is your net28 network card. And then inside that virtual machine, you will need to give it an IP address of 28.100 plus whatever you had on the host. Yeah. So if you're working on a computer that has an address of 28.2, then your Prometheus is going to be 2852, and then your virtual machine, VP0, should be 28.102. Okay, so two stages into the bridging of network 28. So this is how that works. All right, with the network cards on net 30, 31, and 32, we're building these network cards because we will need to have more network cards because we will have more virtual machines later on for the last lab set. Okay, you can test them, so you can actually go into VP0 even while it's running, and you can go to the network and you can click on the detach button of the network card. And then once you do that, I think it's actually a blue X icon. If you click on that, it will remove, the Open Nebula software will remove the network card from the running VP0, and then it will give you the option to attach a new network card. So you can actually attach your net 30 or 31 or 32 network card. And this step, you should be doing it towards the end of the OVS lab sheet, because I do want you to check that your networks 30, 31, and 32 work. Theoretically, they all have the same settings or similar settings. So if you can test one of them and it works, the other two should probably work as well. This mostly pertains to the routing that you need to do later on towards the end of the lab sheet. Okay, so if you can ping google.com from VP0 while it's using net 30, then it will probably work with 31 and 32. All right. Now, things that are important regarding the changes that we're doing to the IP addresses. The reason why we are using these IP addresses, okay, and the reason why this spreadsheet or this table exists is because we want to make sure that nobody has duplicate IP addresses in the network, and we all have strict guidelines of what IP addresses we should be using for each of our network cards. Okay, there's a lot of you, and there's only 3 or 4 of us, so we need to be able to keep track of who should have what IP address, and also, of course, make sure that we don't have the same IP address twice. All right, so what we've done is we've taken a class C network, okay, the network that starts at, let's say, 30.1 and ends at 30.255, and we split it into 64 slices. All right, because we have 48 computers, so we need 48 pieces of this for our computers. This works out to give us 4 usable numbers per slice. All right, so it gives us 2 usable IP addresses, and it also gives us a network and a broadcast address. All right, now this happens because the 256 available numbers, addresses, combinations, whatever you want to call it, on a class C subnet, divided by 64 essentially gives us 4. Okay, so we have the range of 4 available addresses per computer to use. What does this mean for the networking side of things? It means that our subnet mask will change. So we will have a smaller network to deal with. So we will have to make some changes into our operating systems with regards to our network settings. Yes. So if we go back into the lab sheet, and let's say, for example, that we're configuring net 30. Okay, so this is the IFCFG configuration file for net 30. We can see here that we have a start IP address, which is going to be the second usable IP address, because now here we're, oh, sorry, I'm in the wrong place. Let me go to, was it this one? This one, yes. So this is the IFCFG net 30. For how long? Why didn't you speak up sooner? It's all recorded anyway, so don't. Brilliant. Yes, now HDMI, please. Seriously, from the beginning. Awesome. Should I start all over again? I'm too concentrated on this. Okay, so when we're configuring the configuration files for the operating system on Prometheus, okay, we need to create an IFCFG net 30. All right. So this will have this information here. So the network card will be called net 30, the device will be called net 30 and everything. This will be the first usable IP address, as we just said, from this file that you never saw while I was explaining it. It's great. But you all know which file I was talking about, so that's probably fine. So this is the first usable IP address here. This is something that changes and is important, because this changes between net 28 and all the rest. Okay, so for net 28, this number is going to be 23. For net 30, 31, and 32, this number is going to be 30. Because what is this number? This number tells us the subnet mask for the network that we're using. Okay, so the subnet mask that we will be using is this. So that's, let's see if I can do this. 255, 255, 255, 252. Okay, so this is what we see, we humans. Yeah? So computers speak binary. So this translates into what? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is because we've taken the class C network. A default class C network would have 1, 2, 3, 4, 5, 6, 7, 8 zeros, and it would be 255, 255, 255.0. All right, because on a class C network, this would be the network part, and this would be the host part. All right, so it basically, actually, I should be showing this. Good. So it's basically, nice. Tells us how many computers we can have in a network. On a default class C network, when we have all of those bits available for our hosts to use, we can have 254 IP addresses available to use, because this converted into from binary to decimal and so on essentially gives us all of those different combinations. It gives us 256 combinations of bits. Yes, so it's 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 1, 1, and so on. Okay, out of those 256 numbers, we take away two of them for a network address and a broadcast address. So we're left with 254 IP addresses to use inside there. Because we are splitting this into 64 slices, we're making this smaller. Essentially, we're taking away 6 of those bits because we want these to be the networks that we're going to be using. And then we get left with only 2 bits that are left for our hosts. And what are the combinations of them? So we have 0, 0, 0, 1, 1, 0, 1, 1. 4 numbers. Yeah? 4 numbers there gives us 4 numbers here. A network address, a broadcast address, and the 2 usable IP addresses. Okay, so that's where this comes from. The 252 itself is because if we convert this from binary to decimal, we start from 128 plus 64. Oh, I have no space. Plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 and so on. All right, so if we add these bits together, they work out to 252. Essentially, we're just missing the last 2 digits there. Okay, and that's why the subnet mask ends in 252. And also that's why that number in the configuration file is 30. Because of all of the 4 times 8 bits, 32 bits that we use for the subnet mask, we're only using 30 bits out of those, the ones that are enabled, the ones that are 1, for our network size. Okay, so that's why on this file we have a prefix of 30. That's what it means. Okay, 30 bits on this subnet mask that we need to be using for our network width, our network dimensions. All right, so once you configure the IP addresses on Prometheus itself, so once you've done the IFCFG net 30, 31, and 32, don't get carried away and use 31 and 32 here for the prefix. The prefix should always be 30 for these smaller inside networks, yeah? Just the IP addresses here will change. And they will change to 31.9, 32.9, whatever it is. So the range of addresses on this applies to subnets 30, 31, and 32. Okay, you're simply on the same line, just on a different subnet that you're working on. So once you configure your IP addresses on the host itself, on Prometheus, you then need to go into the virtual machine, go into the cloud, and configure the IP addresses inside OpenNebula itself. So you need to go to your networks tab, you need to delete the bridge that's already there, you need to detach it from the virtual machine, If you try to delete the bridge while the virtual machine is instantiated, it will not do it. Okay, it will say permission denied, the thing is in use. All right. So you can click on the little red button to basically remove the virtual machine from the cloud, and then you can actually remove BR0 as well. And you create net 28, net 30, 31, 32 in there. When you create them, on net 28, you will need to have an IP address that is whatever you were using plus 100. Okay, because now, as I said in the beginning of this, you're in the second level of bridging that we're doing. Yeah. So if your host is on 28.9, your Prometheus is on 28.59, and then your virtual machine VP0 should be on 28.109. All right. And then you configure nets 30, 31, and 32. The IP addresses that you have available for these network cards come again from the subnets file, and they are the second usable IP addresses on your list. Okay, you've used the first usable IP addresses on your Prometheus IFCFG config files, so you use the second usable IP addresses inside the virtual machine itself, inside the cloud when you configure them. Now, the detail to this is that you will configure these IP addresses here. However, when you start a virtual machine and you try to use those IP addresses, so you create your template of VP2, VP3, wherever you get to, when you start it up, the network cards inside, the networking inside that virtual machine will not be configured. All right. There is a little option in the template itself that says enable contextualization, and under that it says enable contextualization for the network cards, for the network information. And if you do that, then yes, that will transfer the networking information from your net 20, 30, 31, whatever you've used, inside the virtual machine. If you don't do this, all you need to do is very easy. You just go and you manually configure the IP addresses for your virtual machines from the network card settings on the top right corner of the operating system itself. Okay, so you don't need to worry about that too much. It's not, the end of the world. You can just go and configure the IP addresses manually. So at that point, you will reach the point where you have virtual machines inside your cloud. They're using the second usable IP addresses on network 30, 31, 32, whatever. You want to give these guys internet access. So you want those machines to be able to access the internet and, of course, be able to access each other as well. That's where routing comes into play. So on Prometheus, so everything that has to happen for routing has to happen on Prometheus itself and nowhere else. Okay. So you install FRR, which is our routing software, our routing daemon. And then the first thing that you need to do is you need to gedit the etc. FRR daemons file, where it lists all of the routing protocols that are available for you to use. You find OSPF and you change the no into yes in there. Okay, this means that FRR will use OSPF as the routing protocol. Once you do that, you go into Moodle and you find this file, which is an example of the frr.conf. This is as simple as an frr.conf file is allowed to be. All right. All you need to do here, you need to tell the computer the IP address of your Prometheus VM, because Prometheus is the router. So this is the router ID. And then you will need to tell all of your neighbors that are trying to route as well, which networks you are advertising to everybody else. So you are connected. This line will be the same for all of you and you must not change it. You're all connected onto network 28.0. Okay. And then you all have networks 30, 31, and don't forget to add 32 here as well. So you need to tell everybody what your network address is for the networks that you are responsible for. So this is where you put the network address, which is on this column for your computer. Okay. So depending on which computer you're working on, if you're on Latifi, your network address is 24. So then this file will be 30.24, 31.24, 32.24. Okay. The way that the routing protocol works is all of the neighbors talk to each other and they say, hey, hello, who are you? Hi, my name is 28. Whatever. and I have these networks available to offer you. And then the other router next to it says, oh yeah, my name is this and I have these networks available, and so on. So by all of them talking to each other, all the routers, they all build a routing table, as we call it, and they all gain access to all of the networks that they've been informed about. So when we reach at this point, so next week I will probably have Columbus's routing table up on the board. Columbus is our router in the lab. Okay. And if your routing is working, then your networks, 30 dot whatever, 31 dot whatever, 32 dot whatever, will show up as extra lines on that routing table on our router, on the projector. And that will be the first sign that you know that your routing is actually working correctly. Because you're advertising to other people your networks, the networks that are directly connected onto your computer. Once you do that, then all you need to do is you need to test and see if, yes, okay, you can advertise your network to everybody else correctly. Can you see other people's networks and use them? So the way to do this is to basically be able to ping stuff beyond your Prometheus PC. Okay, so you should be able to ping Prometheus. You should be able to ping your default gateway. However, after you set up routing, you should be able to have full internet access. You should be able to ping google.com from all of your virtual machines. And of course, it goes without saying, if you do want to try it, you should be able to ping other users' IP addresses in our lab as well. So you should be able to ping somebody else's 32.1st usable IP address in the lab itself, as long as they have routing as well. Okay, so this is what you configure on this file. So you just need the network address that belongs to your computer according to the a2.net's file. And then once you do that, you basically enable packet forwarding. So this is disabled by default as a security measure in Linux, so that packets that reach one network card don't automatically get forwarded onto other network cards. And then once you do that, you basically let routing through the firewall, and then you enable FRR and you set it to start every time your computer starts automatically. You go to a terminal and you type watch root -n. This is a command that stays and keeps running and dynamically updates in the terminal. So in that command, you'll be able to see your routing table, and your routing table should contain your networks and everybody else's networks that have routing working. So if you're the only one in the class that has routing working, you won't see anything. Okay, but once people start getting it to work, then this should get updated and should get bigger and bigger and bigger with everybody else's networks. All right, so once you're at that point and you can see other people's networks, then you can go back inside your cloud, back inside the virtual machine that you built in your cloud, open a terminal in there, and trying to ping google.com and everything else. By this point, you should only have really one virtual machine available in your cloud, let's say VP0. Okay, VP0 with a net 30 attached onto it that you can basically ping to the outside world. Okay, so if you reach this point and your virtual machine can ping google.com, it means that you've completed the OVS lab sheet. Okay, ideally, in an ideal world, I would have liked you for this to have happened by the end of this week. But I've seen from the morning group the progress that they have, and they are exactly in the most of them are in the middle of OVS. Okay, so I would like you ideally to be finished with OVS by the end of next week's lab session. All right. So then next week I will explain the last lab set as well, which is populating the cloud, and then you can start working on that for the last week before the Easter break, plus the 2 more weeks that we have after the Easter break. Okay. During the Easter break, if you are here and you're really bored with your life, the lab is going to be open. You can just come in the lab and work on that last lab sheet. Yes? If you do use that time and you do come in the lab and you do get all of your computers working and everything else, you could even show me your work when we come back after Easter. And if it's all finished, I can mark you early and you don't have to wait for the 16th of May. And you can be done with it. You're not laughing now, are you? Okay. So it's totally up to you. You can work at whatever pace you like. It's, I don't care. As long as you get the work done, it just means that you will, if you do need help from us, you won't have it during Easter. unless you hire one of the assistants. It's up to you. Have I told you that you can do this or not? Okay, so I need to send you an email today then. Yes. So you can hire the teaching assistants. I think it's something like £20 per hour, and they can sit with you and help you. They have strict instructions not to do your logbook and your work for you. Yes. So, but they're happy to explain things, how things work and all that. Okay. So, yes, that's the story with OVS and everything about it. The networking aspects of this lab sheet are important, and you do need to understand the IP addresses, the IP addressing schemes, and the subnet mask and everything else. A, because I want you to know them, and B, because there will be questions in the exam. Okay, so don't dismiss this and say, oh yes, I understand I should be using this address, goodbye. Make sure you understand the theory behind it. And if you don't, I'm always happy to explain this as well in class again. Okay. Any questions about all this? Yes.
Sorry, might be part of this or not.
Tell me.
As we are doing this last lab, I always last lab, we are doing on using the protocol, which is the open shortest path first.
OSPF, yes.
With its file, we open shortest path first. Can somebody try to use the other protocol, right?
You can. So it would need to be an interior gateway protocol. Yes. So it would need to be a protocol for a small internal network. All right. If you want to try it, you can, as long as it's a protocol that's in the list of supported protocols in the FRR in the daemons file, then you can try it if you like. It's fine by me. Many moons ago, I'm going to say 15 years ago, we used to use RIP. Nobody uses RIP anymore because OSPF is king for small networks. So really, you can try it if you like. It's completely down to you. All right. Anything else? All right. Thank you very much.